Alright, so let's look at question number 3 as regard to the Lussac's law of combining volume. Before we go on, please remember to like, share, and to subscribe to our channel. Right? So question 3 says 60 cm cube of hydrogen. So we have hydrogen gas H2, right? Reacts with 50 cm cube of nitrogen, so N2 gas. Right? If we have this gas, the likelihood of us to get NH3 is high. Alright, so we're going to get, if all the volume of gases are measured at STP, standard temperature and pressure, which I said they are constant, we need them, calculate the volume of the residue gas. It's very simple, simple like what we've been doing. Right, so in this case, what do we do? Let's put 3 here, right? If we put 3 here, that's 6 hydrogen. And if I put 2 here, 2 times 3, I have 6 hydrogen, and I have 2 nitrogen here. So it's balanced, right? 3 times 2 giving me 6 hydrogen, 2 times 3 giving me 6 hydrogen, and then 2 nitrogen here, right? So the more volume, becomes what? 3 volume, 1 volume, and then what? 2 volume. So their volume are changing at this point. So let's look at the question. It says 60 cm cube of hydrogen. Here we have 60 cm cube before the spark of hydrogen reacts with what? 50 cm cube of nitrogen. Here is 50 cm cube of nitrogen, right? They didn't give us any for product. So for this is our what? Volume before spark, VBS, right? I think this is VBS for us as an abbreviation to that. So what do? We bring this guy out and try and isolate this, make this guy a value of x. So we have 3H2 plus what? N2, right? Here. And here we have 3. Here we have 1. Let's make here x, which is here, and make here 50 to see what we're going to get for this part. If we cross multiply, we have what? X times 1 giving us x is equal to 3 times 50 gives us what? 150 cm cube. That's way high, right? Here we had 60, so you can see that 60 are given, 60 cm cube, which is our given, right, is less than what our result, which is what? 150 cm cube. Can't work, we can't use this, right? This cannot be used, right? We can't use that. Let's do for case 2, whereby we are isolating this, right? The same thing, 3H2 plus N2. Here we have 3, here we have 1, and then what do we have here? We have 60, and let's call here x. If we cross multiply, we're going to have 3 times x giving us 3x, 60 times 1 giving us 60, dividing both sides by 3, 3 is 1, 3 is 1, 3 is 1, 3 is what? 2. So we have 20. Our value of x here is 20 cm cube. So our given was what? 50 cm cube, and our result was what? 20 cm. We can use this, right? For this, you can see that this is greater, so we can use this, right? It means that what we're going to have here during spark, V during spark, volume during spark, here is going to be what? Still 60 cm cube, cannot be high, and here is going to be what? 20 cm cube. We're getting our value. What about here? What do we do here? Let's relate this and this because their volumes, we don't have 3, so we cannot assume something here. Let's relate what we have here to the result. So here we have 3H2 and the result of 2NH3, right? So this is 3 volume, this is 2. That's how we cannot assume. We have to try it out, right? So and doing that, let's make what now? Let's make here 60. Let's put 60 here. Let's put x. Since we are looking for the value of what we have here, we don't have anything here, right? So if we cross multiply, what are we going to have? We're going to have 3x is equal to what? 60 times 2, that's what? 120, right? We divide both sides. 3 times x giving us 3x. 60 times 2 is 120. We divide both sides by 3. 3 will take out 3. 3 is 1. 3 is what? It's 4. So value of x here is 40 cm cube. Now we have a value for our result here, which is what? 40 cm cube. Remember that we didn't have any value here, but we have there. So let's subtract volume after spark. We get the volume, VAL, volume after spark. 60 minus 60 gave us 0. Everything was used up for hydrogen. 50 minus 20 gave us what? Gave us 30 cm cube. That's what was remaining. And here we got 40 cm cube. right? So you might want to write the result. To get the result, we said the volume of what? Of hydrogen. Volume of hydrogen after spark is what? Is 0 cm3. Nothing. It was all used up, right? And then the volume of what? Of nitrogen. Nitrogen after spark gave us what? 30. Got 30 cm cube, as well as the volume of what? Of the product. Our product, which was what? NH3. 2NH3 after spark give us what? 40 cm cube. So the residue gas will equal to what? What we got? 0 plus 30 plus what? Plus 40. That gives us what? 70 cm cube. Sorry, so see how easy it is now. Let's take 2 more questions as regard to the Lussac's law of combining volume to give us a vivid explanation and understanding on how to solve questions as regard to this. Make sure you like, share the video, and subscribe to the channel. Please hit on that subscribe button, right? See you in the next video, guys. Thank you. Let's look at question number 4 as regard to the Lussac's law of combining volume. Remember to like, subscribe, and share the video, right? So 4, we have 20 cm cube of carbon 2 oxide. We have CO plus sparks with oxygen, right? 20 cm cube of oxygen. If we do that, we're going to have CO2, right? So how do we balance the equation? If I put 2 here, I have 2 carbon, 2 oxygen plus 2, that's 4. And I put 2 here, I have 2 carbon, 4 oxygen. So 2 oxygen plus 2 oxygen, that's 4 oxygen. And then 2 carbon. 2 carbon times 2 times 2 gives us 4 oxygen, right? Naturally, this is how the order is going to look like. So we have 2 volume here, we have 1 volume here, we have 2 volume here, right? And then we say 20 cm cube of carbon 2 oxide. Here we have 20 cm cube, right? A spark with what? 20 cm cube of oxygen. 20 cm cube of oxygen. There's no product here before the spark. All of these are volume before spark, right? We've said this over and over. Right, so let's get the volume during spark by taking the cases. For the first case, we have 2CO plus what? O2. This is 2 ratio what? 1, right? Let this guy be sort of formula. Let's make it X and let's put 20 here, right? So it becomes the value for this. If we cross multiply, we know that X is equal to what? 40 cm cube. It won't work, right? So you know that for the given was what? Was 20 here, right? 20 cm cube, and the result we got was 40. It won't work. 40 cm cube. 20 cm cube is less than that, so it won't work. Let's repeat that and make this guy sort of formula, the oxygen sort of formula. So if we have 2CO plus oxygen, yes, our 2 is to 1. Let's here be what? 20, because we have 20 here. Let's make here X. If we do that, what do we have? By cross multiplying, we have 2x is equal to what? 20. 20 times 1 gives us 20. Dividing both sides by 2, x is equal to what? 10 cm cube. So this one will work for us, right? Because the given is 20. The given is 20. Then our result is what? 10 cm cube, and this one is greater, so we can use that. So y here remains 20 cm because it's small. We can't put 40 here. It has to be 20, right? Here we have 10 cm cube. Now since the mole here is 2, the likelihood that here becomes 20 is also the same thing because the mole are the same. So we'll put 20 here, cm cube. If you can try that on your own, okay, using case 3, relate both of them, you discover that you're still going to get 20 because their moles are the same, right? 2 and 2. And then this is the volume during spark, VDS. Let's look at what we'll do. We'll subtract. 20 minus 20 gives us 0 cm cube here. For here, 20 minus 10, we have 10 cm cube. Also for the product, normally we have 20 cm cube. So we've done all of this before. The residue, right? Well, we're looking at the residue gas, right? residue gas will be equal to what? 10 cm cube plus 20 cm cube. That gives us what? 30 cm cube. Very easy, right? So whenever questions arise as regard to Dalton's law of partial pressure, I advise that you employ the method I'm giving you. That gives you a smooth and steady answer. Right, so look at other related video as regard to this, right? I'll see you next video, guys. Thank you.